Good morning, students. Welcome to today's online class. In previous video we covered mass of nucleus is covered and mass defect is also covered, and one more important concept, packing fraction is also covered. A packing fraction explains the stability of nucleus. Packing fraction positive, stability of nucleus is less. Packing fraction negative, the stability of nucleus is more. So that is about covered topics in previous videos. Now in present video, we want to continue the important concepts. The first concept means binding energy. The symbol of binding energy means Be. But what is binding energy and what is the use of binding energy? So binding energy means amount of energy required to bound all nucleons inside the nucleus. To bound all nucleons inside the nucleus is some amount of energy required. That much amount of energy is called as a binding energy. And same amount of binding energy is also used to split all constituent nucleons. For bounding all nucleons and splitting all nucleons, splitting all constituent nucleons, the same amount of energy required. So that is called as a binding energy. And binding energy is also equal to energy corresponding to mass effect is also called as a binding energy. So that is about different definitions of binding energy. So totally binding energy, original definition means it is the amount of energy required to bound all nucleons inside the nucleus. That corresponding energy is called as a binding energy, or it is also called as bounding energy. Next, this binding energy is equivalent to energy equivalent to mass effect. So delta into C square. We are getting answer in terms of joules. But we know mass effect expressed in terms of AMUs. Energy equivalent to 1 AMU means 931.5 MeV. So conversion of this joules of energy into million electron volts is equal to delta M into 931.5 MeV. Delta M is mass defect. Mass defect means we know it is the difference between total mass of nucleons to the mass of nucleus. Delta M Z into MP plus M minus Z into Mn minus Mx. It is the difference between total mass of nucleons to mass of nucleus into 931.5 MeV. So that is about different definitions of binding energy and equation of binding energy. Here Z means atomic number of protons. A minus Z means number of neutrons. MP means mass of one proton. We know mass of one proton value is standard value 1.007826 AMU. Next, mass of neutron 1.008667 AMU. So that is about the standard values of mass of proton and mass of neutrons. So that is about important concept is nothing but binding energy. Next, continuation related concept, average binding energy. So average binding energy, or it is also called as specific binding energy. Specific binding energy. The symbol of average binding energy or specific binding energy is V bar. So next important concept means average or specific binding energy. First of all, what is the importance of average binding energy or specific binding energy? Mainly it explains the stability of nuclear system. Like packing fraction, it is also explains the stability of nucleus. Average binding energy is more, the stability of nucleus is more. Average binding energy is lesser, the stability of nucleus is less. So that is about the use of importance of significance of average binding energy. A definition. So average binding energy can be defined as the binding energy per nucleon. The binding energy per one nucleon is called as average binding energy. Our binding energy means we know Z into Mb plus A minus Z into Mn minus Mx into 931.5 MeV by mass numbers. So that is about the definition and expression of average binding energy. A binding energy per one nucleon is called as average binding energy or specific binding energy. So based on this value, we can estimate the stability of nuclear system. Generally, we know some elements are less stable, lighter elements are less stable, and very heavy elements is also unstable. But moderate mass elements are stable, sir. By comparing to all elements, which element is more stable? Means iron 56 is most stable. Because whose average binding energy is 8.8 MeV. So highest binding energy, highest stable element is nothing but iron 56. So that's why iron never undergoes a nuclear fission as well as nuclear fusion. It has average binding energy 8.8 MeV. Next, comparing to all elements, less average binding energy is proton, whose average binding energy is around 1 MeV. And uranium-238 average binding energy is 7.6 MeV. So that is about average binding energy varying from one element to another element. And average binding energy explains the stability of nuclear system. Its value is more, average stability is more. Average binding energy, stability is less. So that is about the two important concepts. Nothing but binding energy and average binding energy. Next continuation, very important concept. Binding energy curve is there. What is the use of this binding energy curve means? This curve explains how stability changing from one element to another element is there. How average binding energy changes with respect to mass number is there. One element to another element, how stability changes is there. We are already explained. The lighter elements are unstable, and very heavy elements is also unstable, and middle elements or moderate elements are stable. So that is about a binding energy curve. This curve explains how stability of nucleus is changing from one element to another element. So for this purpose, draw one curve. This curve is drawn between average binding energy versus mass number. Mass number taking on x-axis. The mass number A taking on x-axis. And the average binding energy or specific binding energy is taking on y-axis. Intersection point is 0 mass number. It is 0. It is 50, 100, 150, 200 and 250. So on x-axis we are taking mass numbers. Next on y-axis we are taking average binding energy. Generally average binding energy expressed in terms of million electron volts, MeV. It is 2 MeV, 4 MeV, 6 MeV, 8 MeV, and 10 MeV. So that is about the scale on x-axis and y-axis. But how stability of nucleus, how average binding energy is changing from one element to another element. The starting element means hydrogen, 1H1. The starting element means hydrogen whose average binding energy is 1 MeV. So starting element means hydrogen, its average binding energy is 1 MeV. After completion of hydrogen, next considerable element is nothing but helium. Helium having average binding energy is 7 MeV. So helium. And helium having average binding energy is around 7 MeV. After helium, next considerable element lithium. Lithium average binding energy slightly decreases, around 6.5. With lithium alloy. Next, after completion of lithium, next considerable element is carbon, and carbon having average binding energy around 7.5. Carbon, whose average binding energy around 7 units. Next, after carbon, next considerable element is nitrogen. Nitrogen having average binding energy around 7 MeV. Next, after nitrogen, next considerable element is oxygen. Oxygen having average binding energy around 8 MeV. 8 means 6. Next, from oxygen onwards, the average binding energy is increase, and iron 56. Iron 56 having maximum average binding energy, and iron 56 having average binding energy around 8.8 MeV. So from oxygen to iron, average binding energy gradually increases and reaches to maximum. Next, up to 140, up to 170, the average binding energy is almost constant, 170 or 180. So from iron 56 to almost average binding energy 170. Average binding energy is constant. Graph is almost horizontal line. Next, from 170 mass number onwards, average binding energy gradually increases. And the last element is uranium-238, whose average binding energy is 7.6 MeV. So that is about a binding energy curve. So once again observe how average binding energy is changing from one mass number to other mass number, or one element to other element. The starting element means hydrogen. Hydrogen having average binding energy 1 MeV, 0 to 2 madhyalirtade. Almost 1 MeV. Next, after hydrogen, next considerable element means helium. Helium having average binding energy around 7 MeV. 7 means between 6 and 8. Next, after helium, next considerable element means lithium. Lithium having average binding 6.5, 6.5. 7 helium kante kadime. So lithium having average binding energy 6.5. Next, carbon average binding energy around 7.5. Next, nitrogen average binding energy decreases, slightly decreases, 7 MeV. Next, after nitrogen, next considerable element means oxygen. Oxygen having average binding energy around 8 MeV. From oxygen onwards, average binding energy gradually increases and reaches to maximum. Iron 56 having maximum average binding energy, highest average binding energy 8.8 MeV. Next, iron onwards, average binding energy curve is almost constant up to 170. Next, 170 onwards, average binding energy gradually decreases. And the last element, heavy element, uranium-238 having average binding energy around 7.6 MeV. So in this way, the stability of nucleus is changing from one element to another element. Now observe this graph. But what are the conclusions from this graph? Or observe the total graph divides into three parts. The first part, the second part, and the third part. It is first part, the second part, the third part. First part is mass number less than 20, A value less than 20. First part means mass number less than 20. Second part means mass number lies between 20 to 170. Third part means mass number greater than 170. So total graph divides into three parts. The first part, second part, and third part. First part means mass number less than 20. Mass number less than 20 means lighter elements. Lighter elements are in less stable. Their average binding energy is fluctuating. Increase, decrease, increase, decrease. So lighter elements are unstable. For getting stability, lighter elements undergoes nuclear fusion, a combining of two or more lighter elements and forms heavy stable elements. But lighter elements are actually unstable. For getting stability, two or more lighter nuclei combines to form heavy stable nucleus. So combining of two or more lighter forms heavy nucleus means nuclear fusion. Fusion means combining. Next, the third part, mass number greater than 170. Mass number greater than 170 means heavy elements are there. So in case of heavy elements also average binding energy gradually decrease. So heavy elements is also unstable. But for getting stability, heavy elements are splitting. The splitting up of a heavy nucleus into two or more lighter nuclei is called as nuclear fission. Fission means splitting. The splitting of a heavy nucleus into two or more lighter stable nuclei and releasing large amount of energy. So that kind of phenomenon is called as nuclear fission is there. So lighter elements undergoes nuclear fusion. Very heavy elements always undergoes nuclear fission. But middle elements are almost stable. Binding energy curve almost stable. So binding energy curve almost stable means those elements are very stable. So in this way, the stability is varying from one region to another region. First region, third region is lighter elements unstable. Second region means middle elements stable. Average binding energy is more, stability is more. Middle elements having maximum average binding energy, stability is more. Lighter elements having less average binding energy, heavy elements having less average binding energy, stability is less. So that is about the importance of average binding energy curve. The importance of binding energy curves. Mainly it explains the stability of nucleus. So that is about the variation of stability from one element to another element is explained by this important curve is nothing but average binding energy curves, the binding energy curves. Next continuation, very very important concept means nuclear forces are there. Or what is the meaning of nuclear forces and what are the properties of nuclear forces? One by one observe. A nuclear force means The force between two nucleons is called as nuclear forces are there. In first year we know different kinds of basic forces are there. One is gravitational force. Force between two mass particles is called as gravitational force. And second force is nothing but electromagnetic forces. Electromagnetic force means it is existing electric as well as magnetic fields. And third kind of basic force means nuclear forces. The force between any two nucleons, force between two neutrons, force between two protons, force between one proton and one neutron is also called as a nuclear forces. So nuclear forces always exist between two nucleons inside the nucleus system. Such kind of important force is called as nuclear force. But what is the importance of what are the properties of these nuclear forces? What are the properties of this nuclear forces? The first kind of important property is a nuclear force. Nuclear force are strongest in nature. So compare the other basic forces. Compare the gravitational force and the electromagnetic force. Nuclear force always is strongest in nature. We know the ratio between gravitational force, electromagnetic force and nuclear force. We know gravitational force is the weakest in nature. And nuclear force is strongest in nature. The ratio between gravitational force, electromagnetic force and nuclear force is 1:10 power 36 10 power 38. Compared with gravitational force, nuclear force are 10 power 38 times more. It is not 38 times, 10 power 38 times is more. So first important property means a nuclear force is always strongest in nature. Second important property is nuclear force are attractive forces. Between one nucleon and another nucleon, some attractive forces. Between any two nucleons, when attractive force, between any two nucleons, when repulsive forces. If distance between two nucleons is greater than 0.5 Fermi, if distance between any two nucleons is greater than 0.5 Fermi, then force between these two nucleons is attractive. If distance between two nucleons is less than 0.5 Fermi, then force between two nucleons is repulsive. So second important property means when nuclear force is attractive force, when nuclear force is repulsive force. But generally nuclear force is always called as attractive forces. If distance is greater than this value, nature of force is attractive force. If distance is less than this value, nature of force between two nucleons is repulsive forces. And one more important property, nuclear force is also called a short range of force. Why nuclear force is a short range of force? Gravitational force means long range of force. And electromagnetic force is also long range of force. But nuclear force is always a short range of forces. We know size of nucleus is very negligible. In this small space, nuclear force are confined. So that's why nuclear force is always short range of force. It is confined to very small spaces. As per strength, it is strongest in nature. As per range, it is a short range of forces. So finally, nuclear force is also called a short range of force, another name. Long range of force means the remaining two forces, gravitational and electromagnetic force. But short range of force means a nuclear forces. Next, one more important property, a nuclear force is also called as saturation force. Why nuclear force or saturation force? Because every nucleon interacts with neighboring nucleons only. So every nucleon interacts with neighboring nucleons only. This nucleon never interacts with far nucleon. So that's why nuclear force is also called as a saturation force. And next, nuclear force is also called as a charge independent forces. Why nuclear force are also called as a charge independent forces? Because nuclear force never depends on charge. The nuclear force between two protons, the nuclear force between two neutrons, and nuclear force between proton and neutron remains the same. Between two protons, two neutrons, and one proton, one neutron, nuclear force is always remains the same. Adhika nuclear force is also called as a charge independent forces. It is a relation between nuclear forces. If you are considering only nuclear force, it is a relation. If you consider net force, net force means between two nucleons, nuclear force is there, gravitational force is there, and electric forces is also there. The sum of gravitational force, nuclear force, and electric force, that is called as net force. So relation between net force between all nucleons, force between two neutrons and force between two proton and neutron is equal. In case of net force, the force between two protons is less, because between one proton and another proton repulsion force is there. A repulsion force means reduces. So it is a relation between net forces between two nucleons. It is a relation between nuclear forces between two nucleons. Both formulas are very important. Next continuation, very important point, nuclear force is also called as spin dependent forces. Nuclear force are spin dependent forces depends on orientation. If any two particles oriented parallel directions, spin of two particles is parallel, the force between two nucleons is maximum. The orientation of two particles is anti-parallel. One particle is clockwise, other particle is anti-clockwise, anti-parallel. The force between two anti-particle nucleon spin is nothing but less. Parallel means maximum, anti-parallel means less, minimum. So that is about one more important property, means nuclear force are spin dependent forces. And one more last important property of nuclear force means nuclear force also called as mass exchange forces. So nuclear force are called as mass exchange forces. So during the time of nuclear force between one nucleon and another nucleon, they exert some forces. They exert some mass particles. Exchanging of mass particle between during the time of nuclear force is called as mesons. Here mesons are two types. The first one is nothing but pi meson, second one is nothing but mu meson. Again pi mesons are three types: pi plus, pi minus, and pi neutral. Similarly, mu mesons are also three types: mu plus,